This video is going to be a quick conceptual look at overriding functions, overriding class functions. It's going to be first conceptual, and then I'm going to hop into a quick coding demo. This video is a precursor to the abstract base class video. If you already understand virtual, you don't need to watch it, but I'm assuming it's tricky to most of you. I split them up into two videos because I don't have editing software. This just makes my life easier. Anyways. So going into a conceptual look, the virtual keyword allows for the following situation. Let's pretend we have a base class, all right? I'm going to call this class B for base, and let's say it has a print function. Now, let's also say that we wanted to create a class that derives from our base class. And this class we'll call D for derived. And in our derived class, we want to override the behavior of print so that when we do, d dot print, it won't call this print, it'll instead call this print that we implement in our derived class. So that's all I'm going to talk about conceptually. If you don't understand, I encourage you to read your notes or check the Codio, materials, or read Stack Overflow or Google. But I'm going to hop into the coding demo now. So I'm going to start the same way I always start, with some boilerplate code. I'm just creating our main function so we can actually see stuff. I'm going to include, Lord, I cannot type, include IOStream. Jesus, excuse me. Using namespace cd. This is just our boilerplate code. So now getting into the fun stuff, let's create our base class. So we're going to call this one base to follow along with our diagram. And in this base class, we're going to have a public member function called print, void print. And it's going to be very simple. Print from base. Okay. And then I'm just gonna set up our derived class without actually setting up inheritance, just so it's here to work with later. Anyways, if we want to enable overriding of print, we need to include the virtual keyword before our function signature. This virtual keyword is what tells your program or your compiler that print is allowed to be overridden. If you don't have this virtual keyword, you cannot override print, at least not in the way that you might be intending. Okay, so now if we want to actually override, the first step is to publicly inherit the elements from base. And then we'll do the same function signature. Excuse me, I made a typo. Print. And then we include this keyword that tells our compiler that we're overriding print. Keyword to override is just override. And then we implement our logic, which is we're just going to do print from derived. Now, before I continue, I want to make a note that technically this override keyword is optional in C++. In fact, this keyword was introduced in later versions of C++, but making it mandatory would have broken a lot of old code that had already been written. So they decided to just make it optional. But I strongly recommend including this because it can catch errors early when you try to. Now, if I were to instantiate this derived class and then call derived.print, and then run this program, you can see that we are calling print from derived. But that's obvious, right? We already knew that we were going to be overriding this. So this was kind of a given that this would happen. So I'm going to show you a little bit more interesting example that I think will be more relevant to Lab 6 specifically through the form of pointers. So if we were to, again, instantiate derived as derived, we could actually cast this into a pointer of our base class, of type base class, and we're going to call this pointer, and we're going to take the memory address with the ampersand, hopefully you remember from earlier in the semester. This is called upcasting. And it's what I talked about in the slides, and this is totally legal and cool in C++. So now what this lets us do is if we were to call pointer and then dereference it to call the print function, because we indicated that print is a virtual function, when we run this, it will actually call the print function from derived, even though it is a base class pointer. And then similarly, we can still create normal base classes, and then I'm going to reassign the pointer to the memory address with ampersand of base, and then call pointer arrow print. And if I were to run this, we print from derived. That's what's happening here when we're dereferencing our derived class. And then we're also printing from base. So even though this is technically a pointer to a base class, the virtual keyword allows us to almost pull out functions from the derived class and call them even though we're working with a base class pointer. And so why is this useful? What's the point of this? Well, I haven't looked at the lab manual for Lab 6 yet, so this is just going off of my memory, but I believe you have to have a map of account types. But obviously you're working with different account types. You have checking, savings, investment. What upcasting does is it allows you to create a data structure containing objects of one type, even though they're really different types. And I might be rambling a little bit, so let me just try and code it. Okay, I thought I paused the recording. I was trying to remember what I had to do. I guess I didn't pause the recording, but I think I'm fine. Anyways, let's say we have a vector. So let me actually include vector first. Include vector. And I wanted to create a vector that held only base class pointers. And then I'm going to call this vector, I don't know, vec, something simple. And then I'm going to go ahead and delete this just to start fresh. Let's say I have, again, our derived class, derived, and then a base class, base. And then I'm breaking this all up into steps just so you can see what the steps are. So the first step is we initialize it. Then we store pointers we store base class pointers. So derived PTR is equal to the memory address of derived. And then derived base is equal to the memory address of, oh my gosh, of base. Okay. Now, what we can actually do is push both of these back to our vector. So we can do vec dot push back our derived pointer. And this is totally fine. And then we can also do vec dot push back our, oh, I named this wrong thing. I meant to name this base pointer. Okay. We can also push back our base pointer. So even though these are two different types, we're able to push them to the same data structure. And now, if we wanted to access the unique print function in each of these, we still can. So we can do vec at 0, our derived pointer. We can call its print function. And then we can do vec at 1, print. So if I run this, you'll see that the first or 0th element of our vector, even though it is, yes, technically it's a base class pointer, we're still able to access the print class or the print function from the derived class. And then for our second element, or first, however you want to look at it, this is totally normal. This is a base class pointer and it's a base object. So we're able to access the base print function that we defined up here. So that'll come in handy. You can do this with any data structure. You can do this with vectors, arrays, maps. You'll probably have to do something similar for Lab 6. Again, I haven't read it, so don't quote me on that. But this is called polymorphism, where you can write code for different objects that treats them more or less the same. But I'm not quite done yet. I actually did intentionally leave something out. When working with base classes and virtual overriding, you have to, like, you must, this is necessary, you have to include a virtual destructor. I'm not going to explain why in this video because I don't want it to go over too many things. I'll quickly say it has to do with you don't want to leak memory when you destroy your base class pointer. But if you're curious on why this is the case, you can Google it. But all you need to know is that if you're working with virtual and overriding, and especially, upcasting, it's absolutely necessary that you include a virtual destructor. And this fancy terminology equals default. This is equivalent to virtual base this. So you don't have to actually implement any logic inside the virtual destructor. You just have to make sure that your destructor for the base class has the virtual keyword before it. So that's the demo on virtual and override keywords. If you have any questions, please review your notes. Please rewatch the lectures, or you can feel free to DM me, and I'll try to respond and talk you through, I guess, whatever question you have.